This is John. He is going to attend his class at the lecture hall.
我又是来线。
He is hesitating where should he sit to get a better hearing for his class. Let's help out John with some calculation and explanation. As you can see, the speakers are placed in the two corners at the hall. Let's have a brief explanation about how sound intensity level relates with this case by using a drawing.
Before that, let's dive into formula that will be used, which explains sound intensity equals to power over area. This will be the first formula that will be used. P is not the electrical power supplied to the speaker. It is because only a small fraction of electrical power will be converted to acoustic power.
This is an example of how does a speaker emit its sound. So, if we choose the middle seat which is labeled as point A, the radius will be 8 meters. By using the first formula, the sound intensity level is 1.2434 times 10 to the power of negative 3. Maybe you guys will be curious, why do we need to multiply by 2 here? Let's have a short recall of the hall that we have drawn. It is because we have two speakers. After calculating the sound intensity, let's use this formula to calculate the sound intensity level.
So after calculating, we found out the sound intensity level at point A is 90.94 decibel. By using the same formula, let's calculate for point B and point C. After all the calculation, we found out that point A has the highest sound intensity level because it has the nearest location towards the speaker. In comparison with point A, the location of point C is more farther.
We obtain a conclusion, which is the smaller the distance from the speaker, the higher the sound intensity level. Let's have more verification by calculating the corner seats.
By using the formula same with the middle seats.
The first one for sound intensity and the second one for sound intensity level. For the corner of the hall, it actually applies the same concept with the middle of the hall. At corner A, we obtain a sound intensity level higher than the middle seats.
Now, let's calculate for corner B and C and look at the difference. At corner B, the sound intensity level is much more lower than corner A. Corner A and B has a distance difference of 13 meters. By applying our conclusion, corner B for sure will have a lower sound intensity level. This is the calculation for corner C, and corner C has obtained the lowest sound intensity level.
If John wants to pick a seat at the corner, we would suggest him to choose corner B. This can provide him a better hearing which will not let him feel uncomfortable.
What about the middle seats, right? For the middle seats, we would still suggest John to pick point B. Point B at the middle shows the most average sound intensity level which would not harm our ears. This picture shows that the sound intensity level is 80 decibels. 80 decibels sounds high, right? But don't worry. We have to continuously listen to sound for 85 decibel and above for 8 hours to cause damage towards our ear.
Here's a short conclusion. Choosing a right seat in the lecture hall can let you feel part of the story. Sitting too close to the speakers might make you feel tense with the high sound intensity, while sitting too far back might cause you to have difficulty to hear clearly. The best choice is often somewhere in between.